everyone, welcome to our guide today about how to set up automatic schema migrations for your Sequelize ORM with Atlas. Atlas is a database schema as code tool that lets you integrate with many ORMs. Today we will explore the Sequelize integration. So as we mentioned, Atlas is a database schema as code tool, which means that its purpose is to take the data models that are defined in code and apply them to the database. In our case, a serverless PostgreSQL server running on Neon. So ideally, what we want when we evolve our application is a simple way that whenever our data model evolves, we can deploy these changes to the database schema, preferably automatically. And let's see how Atlas helps us do that. Suppose we want to make a simple change to our database schema, such as adding a column. So for example, our users table currently has a name and an email column, but let's say I want to add also a nickname to users and having the nickname be optional. So we say that it can be null. I will create a new branch for this change and create a pull request suggesting this change. Now, the way I've set up this project is that whenever GitHub detects that something changed in my data model, is going to run a GitHub action, and Atlas runs in this GitHub action to actually plan the change. Let's dive into the workflow file while Atlas is running to make our change. So we trigger whenever there is a pull request and something in our data model changes. We start out by checking out the code. We can install Node and its dependencies. We then use a GitHub action to install Atlas itself, the Atlas binary on the GitHub Actions runner. And then we run this is the important part, we run the schema plan action. What schema plan will do is that it will connect to our target database to understand what the current schema is. It will extract the database schema from our Node.js, from our Sequelize ORM project, and compare between the two to see if there is some change that needs to be done. So if Atlas detects that there is a change, it will write a pull request comment with the SQL code that needs to run in order to reconcile the difference between the JavaScript ORM schema and the actual database. Atlas also does something called linting, which means that it will scan the changes and inform you if something you're planning to do might cause some negative consequences. Once we're happy with the change, usually we will have someone approve this and we can merge the changes into our main branch. We've set up our project such that whenever we merge changes to master, to our mainline branch, we will run the same action, but this time a different part of it. So what will happen is that we will check out the code, we will set up Node.js, we will install all of the dependencies, then we will install Atlas, and now we will mark our plan as approved. This is a very important step because we want, during the deployment, Atlas should only run changes if they were pre-approved. We don't want any random change doing something funny to our database. We want to make sure that someone on our team actually reviewed this. And what we can see is that the result of this is that the approved plan is pushed to the Atlas Cloud Schema Registry. This is a web application that you can use with Atlas, and it will show you the different versions of the database and the different plans. For example, here is our plan from 42 seconds ago. So after we finish planning our change, now we want to get the change that was described in code. How do we get it into the target database? So for this, we also have a GitHub action, which we can run. I'm going to give this action the instruction to deploy the latest, the most recent version. We can look at what happens next. Once this action is triggered, it does a few things. So let's look at the workflow file. Of course, it will set up Atlas. This time we don't need Node.js because we already have the plan change in the registry. And now we will run the schema apply action. In our case, we are deploying to the target Neon database. We call this the production environment, and we take the input tag. This is the version of the database that we want to deploy, and we tell Atlas to apply this specific version on our target Neon database. Once this starts running, Atlas compares between the desired state as it is defined in the schema registry, compares it to the actual state, and makes sure that we have a pre-approved plan for this transition. Once this is done, we can now refresh our Neon console, and we can see that indeed the nickname column does exist in our target database. So that concludes our demo for today. If you want to learn more about Atlas, feel free to subscribe to our YouTube channel. See you next time.